This is Ratcliffe here. I just want to explain one more thing. A couple of people today were having a few issues with remembering stuff about exponents, so I just wanted to do a bit of a review. The first thing is to remember that exponents, or indices, it's really just meant to be a shortcut. It's just a short way of saying 3 times 3 times 3 times 3. You can use an exponent to say that same thing faster and a little bit easier. Okay, so that one, 3 times 3 times 3 times 3, you can write as 3 to the power of 4. So that's how you say it, 3 to the power of 4. Beware, the most common misconception is that this is the same as 3 times 4. But you know, and I know, that 3 times 3 times 3 times 3 does not equal 12. Okay, good. So I'm going to do a bit of practice here, and I just want to show you quickly. 5, sorry, it's rubbed off a little bit, 5 to the power of 6 is just like saying 5 times 5 times 5 times 5 times 5 times 5. Easy peasy. Same with 3 to the power of 9. It's really just 3 times 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 3. I think that's 9. 1, 2, 3, 4, 5, 6, 7, 8. One more. Okay? And equally, 4 times 4 times 4 is the same as saying 4 to the power of 3. 8 times 8 times 8 times 8 is the same as saying 8 to the power of 4. So you can see that even though it looks really complicated, it's pretty straightforward. Now, another thing is, when people talk about powers of 2, so anything to the power of 2, like 8 to the power of 2, 4 to the power of 2, they sometimes call it a square. Don't let that fool you. It's got to do with measurement and area. So if you look at this square right here, you can see that it's got 4 units, 1, 2, 3, 4, across, and 4 units down. That's a square. So the way you would get the area of that, you could count them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You would find it 16. But you can also do the same by multiplying this side by that side. 4 times 4. You can also write that as 4 squared. That's why they're called a square. Okay, the same goes with powers of 3, which are sometimes called a cube. So I've drawn my best little cube here with that's too high, too wide, and too tall, too deep. Okay, and that would be 2 times 2 times 2, which is the same as saying 2 to the power of 3. So sometimes that's called 2 cubed. Okay? That's all about cubes and squares. Now, square root, this is what was throwing you guys off today. This symbol looks like that. This is kind of like check mark gone a little crazy. Okay? It's the opposite of squaring. So it does the opposite of squaring. So it's the same as the way that dividing does the opposite of multiplying. Okay? So in this instance, when you see this symbol, you need to think, what times itself equals that number? That's what you want to ask yourself when you see this symbol for square root. Okay, so what times itself equals 36? Well, you know that, that's 6. Okay, so the square root of 36 equals 6. Same here, the square root of 100. Well, what times itself equals 100? It must be 10. Easy peasy. What times itself equals 4? It must be 2. Okay? Now the last term I want to show you guys today is about the idea of a perfect square. That's what we've been playing with so far. It's just when a number makes a whole number square root. So for example, 6 times 6 makes 36. Okay, so the square root of 36 is a whole number. The square root of 36 is 6. Okay, that's a perfect square. So mathematically, you can take the square root of numbers that don't square root evenly. We're not going to do that right now, but it's good to know that what we've been playing with today sometimes is called a perfect square. And I hope this has helped you review indices and exponents. Please let me know if you're still struggling at any point with this information. Good luck.